Well, hello everybody. My name is Berkeley Martinez, and I'm going to give a little talk here about using RxJS and observables in Redux. So this presentation is a React app, and it's live at rxjs-redux-and-wizardry.netlify.com. So if you want to check that out, yeah, it's also on GitHub with the same address. So cool. So as Ben said, I'm the CTO of Free Code Camp, but I also do a lot of other things. I like to say that I am internet taught. So I've been a developer now for over 3 years, and a lot of people say they're self-taught, but I just like that term because I didn't really just come up with all these ideas and concepts on my own and just applied for a job and got that job. No, I use the internet to learn. As many people here have probably used the internet to learn. You can find me on the internet everywhere as Berkeley True. So that's my GitHub, my Twitter, and I think also my Free Code Camp username. So if you're looking for that. I'm also a teacher at Will React. So I'm teaching a class this Friday on RxJS, if you're interested in that. I also like to call myself an RxJS advocate. I think observables are probably the best way to do most of your async logic in the JavaScript world. And it kind of irks me that very few people are actually using this library and relying on things like promises, which are very meh. So we'll go into discussing why that's pretty awesome here. So what's inside? We're going to talk about what observables are, why observables are awesome, and also how to use them in your Redux app. Notice here I'm not saying React app because you can use RxJS in pretty much any application, and specifically with Redux, you can use it with a library called Redux-Observable. So what should you expect? This is going to be a very high-level look at what observables are and how to use them with Redux. And I just want to go over what RxJS is. So I'll be using the term RxJS and the term observables interchangeably, but observables are a pattern, and RxJS is a library for creating observables, and RxJS just stands for Reactive Extensions in JavaScript. And again, and also observables are a reactive paradigm as opposed to an imperative pattern like iterables and generators. So over the years, I've had a really hard time trying to explain what observables are to people in just general conversation. And most of the ways I've come up with have been pretty shitty. They haven't really expressed the concept across. But then I came across this article called Learning Observables by Building Observables. And this is an article by Ben Lesh. How many people here have heard of the name Ben Lesh? Awesome, a couple people, yeah. So he's a pretty prolific developer at Netflix. He's also the core person, one of two of the people behind the new version of RxJS, one of the two creators of Redux-Observable. And he wrote this article, and once I read it, I realized this is probably the best way to explain what observables are, and we're not going to really find a better way. So I just decided to adopt this method and for the future on as I explain these concepts. And I think in one sentence you can explain what observable is just by saying an observable is a function that takes an observer and returns a function. So these are all kind of concepts that we already know except for the observer. So let's break that down a bit. If I were to give you a typing of what this would look like, an observable would just be a function, takes in an observer and returns a function. So we all know what functions are, but what about the observer? What is an observer? An observer is just a plain object, plain JavaScript object, and it has three methods on it: the next, the error, and complete methods. And again, if I give you the typing here, we'll see that it's just a plain object, next, error, complete, and these three methods are functions. Now, what about the return function? So the return function is what we call a teardown function or an unsubscribe function, and it just gives us some way to tear down some sort of subscription service as part of the observable API. And let's update our typing of what an observable looks like. So an observable is an observer that returns some teardown function. Now, what is the purpose of an observable? The purpose of an observable is to connect some observer to some producer of values. Now, what are producers of values? An array could be a producer of values. A WebSocket connection can be a producer of values. Or a reactive database could be a producer of values. Rest in peace, RethinkDB. Well, so a couple people know what that is. So it's my cue that I should probably retire that joke. So. All right, so I've thrown a lot of words at you, but it probably isn't really connecting. And as developers, we probably read code way faster than, we can understand code way faster than we just descriptions of code. So let's jump into what an observable looks like. So here we have a function. We're just calling this function observable. And the first argument to that function is an observer. And in return, this function returns a function. It's just a teardown function. So within this function, we're creating some sort of database connection. This isn't part of the observable spec, but this is something, let's say, could be a WebSocket connection, or it could be some sort of in-browser database connection. And let's say this data source requires you to define 3 methods on it to let it connect to you to that producer of values. So here we're going to specify a method onData, and when this onData is called with a property, we just pass that into the observer's next method. When the database connection experiences an error, it passes that error into the observer's error method. And when that data source connects or just completes, and let's say the data source is no longer going to produce any more values, it notifies the observer that it's not going to complete any more values or produce any more values. And then we return some function here as a way to tear down that database connection. So when you call this function, it's going to call the disconnect and destroy. So this is just going to be the cleanup, right? Disconnect the WebSocket connection, null any values that you're using internally, so we're not leaving any connections around. And so the observer, again, is just a plain old object, plain old JavaScript object with 3 methods, next, error, complete. And in this example, I'm just going to console log everything, but the observer can do whatever you define it to do. So here, for example, whenever I receive a new value from our data source connection, I'm just going to console log that out. Same for the error and the completion of that observable. And now to actually use this function, I'm going to call it like a function, pass in my observer that I defined before, and in return, I get a cancellation function. And at some point in the future, I'm going to call that cancellation function and destroy that database connection. So that's the basic API for an observable, if we were creating them ourselves. But we can make this a little more user-friendly, or in our case, developer-friendly, or increase the developer experience. So what we can do here is let's provide some guarantees to our developers using our library. What if our observer is missing methods, right? So what if we don't want to define the error handler or the completion handler? No worries, we'll just automatically mock those up. What if there's an error in our data source connection? We want to prevent anything from being passed through the next to the completion methods, right? We want the error to essentially stop the production of values down the chain. What if we unsubscribe, right? If we unsubscribe from our data source connection, we don't want the next and complete methods to keep producing values for us. So we want to make sure that those are no longer called after we unsubscribe from our observable. What if there's a completion or an error? We also want to automatically call our teardown functionality. So we don't keep these data source connections around if there's an error that closes down our observable chain. What if the observer itself throws an error? What if I call the next or the error or the complete method on the observer and that causes an uncaught exception? We also want to call our teardown function automatically. What if our observer, we only need one method? What if we just make all of the methods on the observer optional, and we'll just mock those up as part of the process, part of our library. And what if, in most cases, what if we only want to worry about the next value of the observer, right? What if we just pass in a plain function and then wrap that in an object and assume that's going to be our next handler? So let's create a safe observer function. So what our safe observer is going to do is provide us some of those guarantees that we talked about before. It's still a plain function at this point, and we're still getting an observer passed in. But now we have this class where we pass in our observer, and it's going to wrap our observer and provide all those guarantees. And now within our code here, our observable that we defined, we use the safe observer instead of the observer provided by the user. That way, if we don't define some of the methods or something in the observer throws, that's caught by this safe observer and handled correctly. So here we can see that whenever we receive data from our data source, we use the safe observer. In case of an error, we use the safe observer. On complete, we use the safe observer. Everything else is the same as before. And now what I'm going to do is define two different observers. Here, I'm providing an observer that's just an object with only the next and the error. So in this case, I don't care about the completion of that data source connection. I can also define our observer as a plain function. In the majority of use cases, this is what we're going to want. And now to use them, same as before, I just call that observer function, pass in our observers, and we get that tear down function in return. And again, at some point in the future, I tear down that observable. And we can make the whole process developer friendly, not just the observer process. Let's create a class of observable instead of just a plain function. Now what we get is the function we return is now wrapped for us in an object, and we can reuse this database observable that we create over and over again. Here we can see the code within it is still the same, but instead of a plain function, we create a new instance of a class observable. We pass into the constructor an observer, a subscription function. The code within is still the same, but now we don't have to worry about the safe observer. That's done for us automatically by the class. And the use is still the same. I create an observer. Here, in this case, just a plain function, console logging out. Console logging the result by 5. And in this case, what I'm doing here is I'm subscribing to that observable. So now we make our observers lazy. They don't automatically start as soon as you call that function. We can create an instance of that observable and pass it around and use it in different parts of our app. And then to actually trigger the observable, we just call the subscribe method on that and pass in our observer. We still get the cancellation function in return. And again, at some point in the future, I tear down that function. All right, so observers are what fit into this category of the observer pattern. How many people here have heard of the Gang of Four book? What is it? Object-oriented design patterns. In that book, you have the pattern Iterables and Observables. One thing that didn't really make the connection in that book is Iterables and Observables are kind of the same, two faces of the same coin, where Iterables are a pool kind of data source where you ask for the next value from that data source. So if I turned an array into an iterable, I would call the next method and get the next value of the array and keep calling the next method until it returns a done flag, right? Observables are the opposite of that pattern where it pushes the values to you. So once you subscribe to, let's say we turn an array into an observable, once you subscribe to that, it's just going to push the values to you and you have to handle those accordingly. So arrays are a good example of iterables, and arrays can be turned into observables, and just like the array methods in JavaScript, we have some similarities to, we have these operators that are very similar to those array methods in the observable world. So for example, filter, map, reduce. I assume everyone here is pretty familiar with the array.map method, array.reduce, array.filter. So these have analogs in the observable world, filter, map, reduce. So let's go into what that would look like in following our example so far. So if we wanted to add an operator, first we're going to use the same observable class that we did before, and now let's define a function that's going to be our mapping function. Just like array.map, this is not going to be a prototype method, but this is just a plain function that will pass in our observable instance and a projection function. And then internally, what we can do is call the observable class again and create a new instance that we return. Unlike our previous examples here, instead of just passing the value from our producer in this case is the source that we pass in, we actually call the value from our source into the projection function, and that the return from that function we pass to our observer. So you can see here we have a map observer, and the next method here, instead of just passing in the value, we pass that value into the projection function, and then that value from the projection function gets passed to our observer. And because we have no real living thing in this producer value in this operator, instead of creating our own teardown function, we just pass the teardown function from our source as a teardown function for this observable, and that helps us, reduces some of the overhead for us to manage. Now to actually use it, just like before, we create our observer, we create an instance of my database connection above, and now we call our map function with our instance as the source, the first argument, and then we provide a projection function. In this example, we're just using a function that takes any value and multiplies it by 5. And just like before, we have a cancellation function, and at some point in the future we call that cancellation function to tear down. So it would get pretty unmanageable if we needed a lot of operators, right? So sometimes if you're using arrays, if you're doing a lot of array math, you're constantly mapping and reducing and filtering. It would be really, let's say, ugly if you had to keep passing in the previous value of the map into the next map. So instead, let's add this functionality to the prototype of our observable class. So just like before, we create an instance of my database observable, and now the observable class, we just add this map method, and instead of passing the source directly into the map, we use the context of this method as the source. Just like before, we create a new observable and pass that as the return from the operator. So you can see here the observable, still console logging out, but now on my database observable instance, I just call the map method directly. And then what I get in return is another observable that I then subscribe to. Again, some point in the future, I call the cancellation method and I tear down. So whenever I have these conversations about what RxJS is, a lot of people always like to tie this observable world into the promise world, right? So promise is part of spec. Why don't we just use promises for everything? Well, there are a couple good points here that I like to talk about why you should not use promises and instead use observables. So one of the big things is promises are always async. You have no say in that matter. But observables, as you've seen from our previous slides, you can make observables asynchronous or synchronous. It really depends on your producer values. So you have that choice there. You have that freedom to go one way or the other. Observables are lazy, while promises are eager. What does that mean? If I create a fetch request using a new fetch API, and I'm trying to make a GET request to an API endpoint, that AJAX request is in flight as soon as I call that promise. But with observables, if I use the observable AJAX methods, I can define an API request and then use that in some other point in my application. I can pass it around, I can map in one place, reduce in another, and then when I'm ready to call them, I just subscribe to those different observables. And that leads me to the next point, or nope, never mind, that's down below. But anyways, that makes observables reusable. Because they're lazy, I can create one observable and then just clone it and pass it around to different places. And I can manipulate those properties and essentially create a very flexible API using one source of observables. Another thing you might have noticed here is observables are multi-value. Promises are always single value, and while that gives you some benefits, it means that you can't distribute the items throughout time. You only have one handler to respond to that promise. Observables, on the other hand, can produce any number of values throughout time, infinitely if you wanted to, as long as your computer was running. So why are observables awesome? One, they're very powerful. There's very little you can't do with observables. I haven't seen an example that I couldn't think of some way to apply observables to that problem. One of the great things about observables is you can declaratively write async code. There are very few options to do a declaratively async code. And another point is composability. Because observables are lazy and reusable, we can compose many observables together, map over those functions, filter, reduce, pause them, and restart them throughout our application. Now I want to give you a very quick example of what one of the very powerful features of observables. If you look at any sort of observable tutorial, one of the things they always say is, one of the things, examples they always give is this autocomplete functionality, and I have to go do it on this screen here. So this is a Wikipedia search with autocomplete here, and just to give you an example of what it can do is, what we're doing here is we're just querying the Wikipedia API for articles that it has in relationship to React. So what I'm doing in the background is I'm taking the user input, I'm filtering out for inputs no longer than 2 characters, debouncing that input, and then I'm making an AJAX request to the Wikipedia API, and then I'm also, because of the way observables are built, I can declaratively cancel a previous request that's still in flight when I make a new request. So if I were to, I'm also debouncing and filtering for character length, so I can do things like this and wait for the user to stop input, and then it'll do the AJAX request. Or I can also wait for it to start a new request, and it'll cancel the previous one in flight. So we're going to talk about how to add observables into your Redux app. So a really nice library out there now is called Redux-Observable, and it's created by Ben Lesh, who I mentioned before, and Jay Phelps, both from Netflix, both from the Netflix team. Very intelligent and smart people, way smarter than I am. I have a very nice library here, Redux-Observable, and it's a very elegant and idiomatic way to add observables into your Redux app. One thing that Redux doesn't do, and just like React, is it doesn't really have a story for async stuff, right? So most people, when they start learning Redux, they'll start using things like Redux Thunk. But once you start building really large apps, you start to realize that Redux Thunk becomes very limiting and very hard to manage and very hard to compose into smaller bits that you can later put together. Redux-Observable provides a really nice API that lets you create composable APIs or composable async or side effect stuff for your Redux app. So why should you use Redux-Observable? Again, the power of Redux-Observable comes from RxJS, and observables themselves are very powerful. So that means Redux-Observable has a very small API surface, and because of the fact that observables give you 3 tracks, right? You get the next, the error, and the completion track, as opposed to promises who just have the next and the error track. You actually get server-side rendering with data prefetching free out of the box. And I created a library to do that with Redux-Observable. Observables are also idiomatic in the fact that what I've shown you in the previous slides are just what you've probably been using in JavaScript for your entire developer life. Functions, prototype chaining, classes, these are all things that have been in JavaScript for a long time. There's no new API that you need to learn. Functions, chaining, and everything we're talking about here are functional concepts, right? Filter, map, reduce. Once you learn these few concepts, you become a very powerful developer. I'm going to go into what an epic looks like. Then I'll go into what the code looks like for our autocomplete example that we had before. So now let me just define what an epic is. And again, we're just talking about idiomatic JavaScript terms. So an epic is a function that takes a stream or an observable of actions. These are actions from a Redux app, actions that are sent through the dispatch. It receives a stream of these actions, and then you filter for a specific type of action, and then you cause some action or some side effect to happen within this epic, and then as part of that side effect, you return actions that then get dispatched into your Redux app. You can think of this as sort of a process manager or sort of a way to turn events into commands in your app. So here we have a plain function, and we're going to call this function fetch challenge epic. It's going to take an action stream. Here the actions is an observable instance. And what I'm going to do here is I'm going to chain a couple properties on this instance. The first operator I'm going to call is the of type. This is just filtering for the action type in your Redux app. Here I'm filtering for the fetch challenge action. So whenever I see the fetch challenge action, I'm going to start this process here. So I'm going to talk a little bit about switch map here. How many people here are familiar with flat map? Or how about, not too many people, how about filter, right? Array flatten. Right? Flatten is not part of the spec yet. And what about the map, array map, right? That should be almost everybody. Flat map is the combination of these two. So let's say you map over an array, and in return you get an array of arrays, right? You go from a 1D array to a 2D array, and then you call the flatten operator off on that array. What that does is it turns the 2D array back into a 1D array. So flat map is the same thing except in one operator. You flat map, turn a 1D array into a 2D array, and then you flatten that back down into 1D array. So what you get is an array that projects and increases in size. So if you apply that concept to observables, it's kind of a straight one-to-one. But the problem is observables can live throughout time, right? So they don't spend all their values and then stop. We can have an observable that only produces a value every 3, 5, 10 minutes, right, or hours. So the concept of flat map doesn't really apply directly, because if we were to have an observable produce a value and then project new observables to that, one observable that doesn't end would mean that the observable never produces a value downstream. So we have this concept of a switch map, and what a switch map does is when it receives a new item that is projected into a new observable, it cancels the previous observable. So what that means, in effect, is we get Ajax cancellation declaratively out of the box. So we don't have to worry about doing that stuff manually. And that's what we're using here is a switch map. We pass into the switch map operator a projection function. It's going to take, for every value, in this case for every action fetch challenges, it's going to call and create a new observable that is a service request or an API request. It's going to make an API request to my challenges endpoint, and when that request, the AJAX request completes, it's going to map over the values returned and map over those values and produce action and an action in return. And then it's going to, that observable instance is passed to switch map. Switch map handles subscribing to that observable and then canceling that observable if a new fetch challenges request has been made. I'm also providing a catch handler here. So if you've used promises before, you are familiar with the catch method. Essentially, it's the error handler for the promise. With observables, it's a little different. Because promises are always single value, you can make some assumptions with promises. But with observables, because they can produce any number of values, 0, 1, or infinite, we can't assume that what we're getting in return is going to be the one value that we send in place of handling that error. So the catch method in observable is slightly different than the catch method in promises in that it expects you to return some observable in handling that error. So in our case, we're going to return an observable of just one item. And this is an item, an action of type handle error. So that's the basics of an epic. It's just a function that takes a stream of actions and returns a stream of actions. Now let's go into our autocomplete method, or autocomplete epic. So this is a very declarative way to write an autocomplete function, to add autocomplete functionality to your app. Again, this is an epic. It's going to get a stream of actions. I'm going to filter for the search wiki action type, and this is going to be our action type. We filter over the payload. The payload is the event object from the input field. And one thing I want to point out here is I have a couple numbers listed here, 1, 2, 3, 4. They'll come into play in a moment. So what I'm first going to do is I'm going to map over the value. I'm going to project the event object from the input field and just grab the value from that input field, event.target.value. I'm going to filter that input field and I only care about the input fields where there's more than 2 characters there. So if it's less than 2 characters, it's just going to stop right here and wait for the next search wiki event. And then I'm going to debounce the input from the user. So here's a ½ a second debounce. And then I'm going to use distinct until changed operator, and it's a very descriptive operator here. What it's going to do is it's going to wait until the value that it's seeing has changed from the previous value. The first search wiki is automatically passed through because there's no previous value. But the second time you trigger that search wiki, it's going to check if the 2 input fields have the same value. If it has the same value, then it's going to filter it out. If the value has changed, then it passes down. So that's step 4 here. 5, we're going to use our old friend switch map. Again, we're going to pass in the input of we're going to pass in the value of the input field, text, and we're going to pass it to the search Wikipedia function. This search Wikipedia is going to give me an observable in return. So this switch map is going to see a stream of observables, and it's going to subscribe to those observables and cancel any previous observables still in flight if it receives a new request. So now when this AJAX request is complete, I'm going to call a map operator. So I'm going to get this AJAX object in response to that search Wikipedia request. I'm going to grab the response property of the AJAX object, and then I'm going to check the data I'm going to check the length of that. So for the Wikipedia API, what you get back is an array. And the first value is the actual search that you sent in to Wikipedia, and the second value of that array is the actual array field of articles from Wikipedia. So what we're doing here is we're just checking that payload set from Wikipedia actually has 2 values. And that tells us that Wikipedia actually has some results for us to display. And now what I'm going to do is going to map those values into an action and then pass that into Redux-Observable, and that's going to be dispatched for us. And now in my reducers, I can handle this search Wikipedia complete somewhere to display those values to the user. Now I mentioned the numbers here, and these are going to come into play in the next slide. One thing I do want to say is, being around in the Rx world for a long time, I've seen tons of examples of this autocomplete functionality done in RxJS. One thing I have never really seen, and haven't really seen anyone talk about, is how would you do all this using imperative APIs, using AJAX, using promises, using the DOM API. And then I came across a really interesting GitHub repo. And some guy actually took the time to write this out using nothing but current DOM API, current web technologies. And so what I'm going to show you now is how these operators map to a declarative API. And I gotta tell you, it's not pretty. So the source here is in this slide of where it comes from. So let's talk about number one here. So I'm using an event handler here. I'm just passing an event handler to the DOM element add event listener. When the value of this input field changes, I'm going to grab the event object and map over this imperatively. Then I'm going to filter. If the value of the input of this text is not greater than 2, I'm just going to filter out, just using an if statement here. And so if it is larger than 2, I'm going to debounce and search. So this debounce here is going to check the previous value first. This debounce and search is going to wait until a certain amount of time has passed to actually make the new request. It's also going to distinct until change here. So it's going to check the previous value from the current value. And so what I'm doing is I'm actually storing a reference to the previous value in this code. And when this function is called, I'm checking against the previous value. And if the previous value is there, if it's the same, then I just store the previous value and make a search Wikipedia request. So now the search Wikipedia request is going to use XHR or Ajax to make that request. But it's going to return a promise here. So here's a switch map. What I'm doing is I'm storing the previous XHR request object, and I'm checking if there's a previous XHR request object, I'm calling the abort method. And that's how you would do cancellation. So if there's a previous one in flight, this will cancel that request in flight. I'm going to create a new XHR object. I'm going to store in the reference for the future. I'm going to do the XHR stuff, right? And then I'm returning a promise that'll handle the XHR onload and the on-error requests. So I make this GET request, pass in the URL, and then I map over the response. Because we're using SHR, we need to make sure that we're actually parsing the response as a JSON object because it comes back as a string. And then how do you filter over a promise? Does anyone know? You can't, right? You can't really filter over a promise because the promise is a single value. You either get the value or you don't. And then I'm going to finally going to map over the value, and then this is going to go into some set state part of the app, right? So here, this set state. That's how you do it declaratively or imperatively. And again, just to show you what it looks like. Let's see if I can spell. Nope, I can't spell. Declare. So one more thing I want to show you before we move on, before we wrap up, is I just want to show you how simple the API for Redux-Observable is. This is going to be like the create app store file in your app. This is what you define here. And from Redux-Observable, I'm going to pull in two functions here: combine epics and create epic middleware. And combine epics is what it's going to do is it's going to take a bunch of epics. Remember, epics are just functions, right? Plain functions take in a stream of actions and return a stream of actions. And because they're just plain functions, we can compose them together. We compose them together and we get one root epic. And the root epic is the same thing as a normal epic. It just takes in a stream of actions, and then in return you get a stream of actions. And then we do our normal stuff here, like create our reducer, and then once we have our root epic, we pass that into the create epic middleware. So then this wraps that plain function into the Redux middleware API. You get an epic middleware return, and then just like a regular app, we'll create our store, and then we pass in the epic middleware into our apply middleware function provided by Redux. And that's it. That's the entire API for Redux-Observable. Yeah, and so if you want to use Redux today, or if you want to use RxJS in your Redux app, you would use Redux-Observable. So this is the GitHub repo for this Redux-Observable library. There's also a Gitter API or a Gitter chat room for this that I'm also very active in. So if you ever have questions about that, this is normally what I would ask for questions, but I don't know if we have any time.
Yeah, no, we actually don't have any time, so
yes.
we're going to have to wrap it up. So let's hear it for Berkeley.
Thank you.